This video introduces the activity-based travel demand model that has been implemented in the POLARIS agent-based modeling framework and demonstrates how the demand behaviors and results are visualized through the graphical interface. First, some background on the POLARIS agent-based model. The POLARIS activity-based model consists of agents such as travelers, network elements, and a traffic management center which take actions governed by behavioral rules. The focus of this video is on the implementation and visualization of the activity-based travel demand behaviors of the person agents, which determine how the agents interact with the transportation system. The behavior of traveler agents in POLARIS are derived from an activity-based model. Activity-based models are designed to simulate the activity travel engagement of individuals. They develop reasonable activity travel patterns for each individual subject to a variety of constraints, including spatial, time, and resource constraints. For example, car usage within a household. The activity travel pattern, or schedule, is developed to satisfy individual needs according to some optimizing or satisficing criteria. The models rely on a number of inputs. Individual and household level socio-demographics are used to describe the agents. Environmental attributes such as land use patterns, activity locations, transportation networks, and their service characteristics are used to inform and constrain decisions. Finally, some models also take into account the behaviors and actions of other individuals when agents make activity travel decisions. The decisions that are modeled generally include the choice of which activities to perform, where, when, and for how long the activities will take place, whether other agents will be involved, and the travel mode to use. Some models, such as the ADAPS model on which the POLARIS simulation is based, also model the sequencing of these decisions. A full description of the ADAPS model can be found in the reference shown here. The ADAPS model is a dynamic activity-based model which implements several agent behaviors related to activity travel planning and scheduling. The behaviors fall into four categories: activity generation, activity planning, activity scheduling, and traveling. The behaviors interact as shown, where the agent is continuously checking whether to generate, plan, or execute activities as the simulation progresses. The activity generation behavior represents the agent trying to meet their various needs by deciding to engage in new activities, such as working, shopping, socializing, and so on. When a new activity is planned, it is added to a planning queue, and the order of the planning decisions is determined. Then, as the simulation progresses, those decisions, such as destination choice, mode choice, etc., are made at the scheduled times by planning behavior models. Once the activity is completely planned, the scheduler attempts to add the activity to the schedule using a conflict resolution and scheduling process. Finally, activities are executed at their specific start times by having the agent choose a travel route, then traveling through the transportation network along the route to the next scheduled destination. Next, a series of interactive visualizations will be shown, demonstrating how the activity travel demand components and resultant measures can be viewed. The demonstration includes showing the overall activity travel pattern for any simulated agent, viewing aggregate production and attraction counts by zone, and plotting aggregate demand characteristics over time for all agents. We have allowed the regional simulation model to run from approximately 5:20 a.m. in the morning in order to build up enough demand for demonstration. At this point, the agents in the model have been planning and executing activity and travel episodes. The agents currently in the network mostly represent early morning commuters. Notice the realistic traffic flow patterns heading to the downtown area. We can now turn on the routes and locations layers. By simply mousing over or selecting one of the vehicles, this will allow us to visualize the agent's planned time-space prisms. Let's look more in depth at this agent's travel plans. This is also shown in the Attributes window at right. We can see that this agent has a fairly simple activity pattern. She does some early morning shopping, works for 8 hours, then eats out at a restaurant for dinner before heading home for the day. Let's turn the vehicle layer off so we can see the activity pattern more clearly. The display now shows the activity travel pattern as a series of red bars representing activity episodes. These are connected by a series of sloping green lines representing travel episodes. Notice that the time dimension is shown in the z-axis direction, and that by rotating we can clearly see the temporal pattern of the plan. By rotating to a flat XY projection, we can also see the pre-planned activity pattern, which is displayed as blue lines connecting the activity locations. This becomes important later on as activity replanning occurs in response to events. For now, though, this pattern is the same as the current activity plan. The route that the agent has selected for the current trip is also shown in the light blue color. It is important to note here that all of the activities shown are provisional and can change throughout the day, and the differences between the pre-planned pattern and current pattern would become apparent. Now that we have seen the results for one agent, let's look at some more aggregate demand characteristics available in the model. If we turn the vehicles layer off and the zones layer on, we can look at trip productions and attractions by zone. If we zoom in on the downtown area, we can see the blue and green bars, which are centered at the TAZ centroids. The green and blue bars represent the trip productions and attractions for each zone over the past 5 simulated minutes respectively. As the simulation progresses, notice that the heights of the bars are updated as a 5-minute interval is completed, showing the new demand estimate. The demand for the current simulation shows the downtown region of Chicago is attracting many trips and producing few trips in the AM period, as would be expected of a central business district region. It is useful to be able to perform such spot checks when evaluating the performance of the model. The visualizer also currently has several automatically generated plots showing aggregate demand characteristics, which are updated as the simulation progresses. I will pause the simulation so we can look at several of the plots. If we click on the Activity Type Distribution tab, we can see a plot showing the counts of the planned activities for each activity type in red, and the count of the actually executed activities of each type up to the current point in blue. The executed activity count will continue to grow as the simulation progresses. Notice in this period of the AM peak, a high fraction of the work activities have been executed while few other activity types have been generated as expected. Next, we can view the current travel time distribution. This plot shows the distribution of simulated travel times for trips that have completed to this point for all travelers, and is an important measure of model performance. Finally, there are several plots showing counts of the replanned activities, canceled activities, and overall time lost due to unexpected congestion, network events, and ITS information. As agents modify their plans during the simulation, these plots are updated. Nothing is shown here at the moment, however, as no network events or ITS controls have been specified. This concludes the introduction of the activity-based travel demand model within Polaris.